Hey guys, this is Carrie, and this is the answer key video for the group quiz. So let's take a look at some of these problems. Determine the value of this. So personally, when I have a subtraction problem, I like to make sure to distribute the minus sign, so minus a minus becomes plus. Minus 4i here. Combining like terms gives us 7 plus 3i. For problem 2, the implied operation here is multiplication, so we distribute, giving us negative 10 plus 8i minus 35i plus 28i times I is I squared. Here we can recall that I squared is actually the same thing as negative 1. So we're going to get negative 10. Combining like terms here gives us negative 27i plus 28 times that negative 1. That will give us negative 38 minus 27i. Here we've got negative 5 plus 4i squared, so that will be negative 5 plus 4i times negative 5 plus 4i. Remember, when you square something, it means that whole thing times itself. So make sure that you do that. Now we distribute out 25 minus 20i minus 20i plus 16i squared. 25 minus 40i when we combine the like terms, plus 16, and then this I squared becomes negative 1. So that's going to give us 25 minus 16, which is 9 minus 40i. For problem 4, when a plus bi squared is fully simplified, the result is, so again, when you have it squared, that means this whole thing times itself. It doesn't matter that they're letters here. We get a squared plus abi plus abi plus b squared. B times b, I times I is I squared. That gives us a squared plus this one and this one make 2abi. And I just circled this earlier to remind myself that I can convert that to negative 1. And this all becomes a squared minus b squared plus 2 abi. Wrong choice, right? That shouldn't have been that one. A squared minus b squared plus 2 abi. Okay. Which expression is equivalent to this? Where I is the imaginary unit. So, man, we've got a lot of these squaring ones. We've got 3k minus 2i times 3k minus 2i. Now I'm going to do this part first. So we get 4i, and then 3k times 3k is not 3. 3 times 3 is 9. K squared minus 6ki minus 6ki plus 4 I times I gives us I squared. I'm going to simplify this completely before I continue on. So this is 9k squared. Combining like terms here gives us minus 12ki. Oops. And then this is plus 4 times negative 1. So that's going to be minus 4 in total. Then we distribute the 4i, so we get 36k squared I minus 48k I times I is I squared minus 16i. So we get 36k squared I. This one we have an I squared. That becomes negative 1. Negative 1 times negative 48 makes positive 48k minus 16i. And now we need to pick which of these is the answer choice. And it looks like it was this one. Graph each of the following complex numbers. So remember, you graph the real part as the x-coordinate, and then the imaginary part as the y-coordinate. So we go right 2, down 5. This is 2 minus 5i. Back 4 for the x-coordinate. Up 3 for the imaginary coordinate. I is just 0 in the real direction, and then 1 up. So this is I right here. And then given that the complex number z equals a plus bi, if a is less than 0, so to me that means we're going to go in the x direction. Less than 0 is a negative number, we're going to go back. B is greater than 0 means in the imaginary direction we're going to go up. That means that we're going to be in quadrant 2. Solve the following equation for all values of x. It looks like dividing by 2 is not going to work too well here, so I think we've got to use the quadratic formula. So the quadratic formula is negative b plus or minus, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we identify a, b, and c. So substituting those in gives us x equals negative 6 plus or minus the square root of 36 minus 4 times 2 times negative 9 all over twice a, which is 4. X is equal to negative 6 plus or minus the square root. Negative 4 times negative 9 times 2 is 72 all over 4. X is equal to negative 6 plus or minus the square root of 108 over 4. If we want to break 108 down, that breaks down into 9 and 12. That breaks down into 4 and 3. And then we've got, oh, let me just leave. Sorry, it's okay. So then here we get 9 is the same thing as 3 squared, 4 is the same thing as 2 squared. So we get x equals negative 6 plus or minus the square root of 3 squared times 2 squared times 3. And when we have the square root to cancel the squares, these cancel out. Oops, I forgot to put the over 4. And that gives us x equals negative 6 plus or minus 3 times 2, square root of 3 over 4. X is equal to negative 6 plus or minus 6 root 3 over 4. And here all of these can be reduced by 2. So we reduce by 2 on top and bottom, and that gives us x equals negative 3 plus or minus 3 root 3 all over 2. So that was a really long one. Sorry I didn't give you guys too much room for it. Let's just finish up by doing this last quadratic formula problem right here. So I'm going to use the same formula to solve this one. So it'll be x is equal to a, b, c, negative 4 plus or minus the square root of 16 minus 4 times 3 times 7 all over 2 times a is 3, that's 6. X is equal to negative 4 plus or minus the square root of 16. 28 times 3 is 84 minus 84 all over 6. X is equal to negative 4 plus or minus the square root of 16 minus 84. I'm just going to do 84 minus 16 and switch the sign. So that's 8, that's 6, 68 over 6. But I forgot. It's actually negative 68. Sorry about that. And now we have to break 68 down. So I'll do that wherever I have room. 68 breaks down into, let's see, 2 and 34. 34 breaks down into 2 and 17. And so we get x is equal to negative 4 plus or minus the square root of, I'm going to break this negative off, negative 1, times 2 squared times 17 all over 6. X is equal to negative 4 plus or minus the square root of negative 1, that's I. Square root and square cancel here, giving us 2i root 17 over 6. And now we can reduce the whole numerator, this term, and this term, all by 2. And we do that giving us x is equal to negative 2 plus or minus I root 17 all over 3. That was a tough one, but the key idea, right, is when you have a square root of a negative, it has to give you the imaginary number I. So I hope this is helpful, guys, and I'll see you in class for the quiz on Thursday. Bye.